you are going to be asked to write expressions based on percent problems. Even if you are used to doing it proportionally, one of the standards that New York State asks us to be able to do is to write expressions and identify expressions based on percent problems. So this is actually part of last unit when we identify that it's a expression and equations Common Core standard. But I kept it for this unit because it really fits nicely into the percents problems that we've been doing. So you will have to be able to write an expression for markups, discounts, percent of changes using percent expressions. And you'll be asked to identify a percent expression as a relationship, either a markup or a discount or a percent change problem. So some of us have been using the proportion method to solve percent equations, and some of us have been using the percent method. So everybody is going to have to recognize a percent expression. You're going to have to be able to write it and recognize it. Even though you don't necessarily have to use the expression to solve the percent problem, you will have to be able to use a variable to write that percent expression. So we're going to go through a couple. Hudson's amount of M&Ms is increased by 5%. Write an expression for this scenario and simplify it. We don't know the amount that Hudson starts with. So like any problem where we don't know the amount, we're going to say let x equal Hudson's and M&Ms. And we know that Hudson's M&Ms start at x. We also know that it's going to increase by 5% of what it originally is. Well, if we want to know what 5% of x is, we would write 0.05x, because 0.05x would determine how many M&Ms it increased by. So if Hudson happened to start out with 20 M&Ms, we know that the 10% rule would have said that 10% of 20 is 2, so 5% of 20 is 1. So he would have increased by 1 M&M. If he started with 20 and he increased by 1, he would end up having 21 M&Ms. What you did there was you added. So when you're trying to find out the simplified expression, you're going to add his original amount, which is x, to the 5% increase, which is 0.05x, and you're going to end up with 1.05x. So 1.05x will get us directly to the ending amount of M&Ms that Hudson had after it increased by 5%. So in this case, once we have a simplified expression, we can make Hudson's M&Ms anything we darn well please, and we would end up getting a 5% increase based on that amount. So like I said, if you started out with 20, and then you did 0.05 times 20, it would be 20 plus 1 would be 21. The same thing you would get if you multiplied 0.05 by 20 on your calculator, you would get 21. So 1.05x would be a simplified expression to represent the increase of 5% in Hudson's M&Ms. So a shirt was on sale for 25% off. Write an expression for the situation and simplify it. So let x equal original dollar amount. So my original dollar amount is x. In order to find 25% of x, one of the ways that I could do it is multiply by the 25% as a decimal, which is 0.25 times the original. And since it's on sale, we're going to subtract original minus discounted price, and then we would get that the sale price, the amount that it's actually going to be sold for, would be 0.75x, or 75% of the original, because the original is 100% and the discount is 25%, which means the sale price would be 75% of the original amount. So a shirt is bought and marked up, so now the price is going to be increased from the original price. So X is still going to be defined as original dollar amount. And so now you're going to have X as your original dollar amount and 0.8X or 0.80X as the amount, the dollar amount that you're going to add to the original in order to get the marked up amount or the selling price, which would be 1.8X, because we always remember that there's always a 1 in front of X. So whether we're adding or subtracting, we're remembering that there's a 1 as the coefficient of X. So it's 1.8X. So the marked up amount, the selling price, the price that you pay after you've marked it up, is 180% of the original, because the original is always 100% of itself. You're adding to it an 80% increase, which is basically saying you're taking 80% of the original and then adding it on. So the selling price is 180% of the original amount. A pair of sneakers is on sale for 30% off. Off means subtract of the original price. X equals original dollar amount. So you're taking the original dollar amount and you're subtracting 0.3X or 30% of the original. So the sale price of the sneakers would be 0.7X or 70% of the original. Toshio bought a used car for X dollars. 1 year later, the value of the car was 0.88X. Which expression is another way to describe the change in the value of the car? So the original price was X, or 100%, or 1X. And now all of a sudden the new price is 0.88X. So right away you should be saying to yourself, well, the second price is less than the original price, so we know it's a discount. And then we have to figure out what the discount would be. So you're saying, well, how did you get from the original price to the discounted price? And that means it was the change in the value was 12%, because 100% was the original value of the car and 88% is the new value of the car. So that means that when you wanted to find out what the difference is, it was 12%. One more markup question, because these seem to be the trickiest. Richard buys a hockey stick for X amount of dollars and marks it up 120% before he sells it to a friend. So I don't need X statements because X is already defined for me as amount of dollars. So my original, Richard pays X dollars and he marks it up 120% of the original before he sells it to a friend. So I made 120% into a decimal like I did for everything else, except now, unlike everything else, there's a 1 because I'm marking it up more than I paid for it, or he's marking it up more than he paid for it. So that means the selling price of the hockey stick is 2.2 times the original value, because 100% is the original. He marked it up 120%, which means he sells it for 220% of the original.